Hello everybody. Just going to put this box up. I usually like to store whenever I buy something for, I like to keep the box a month or two in case the item breaks. You can put it back in the box, send it back. So I usually store them in the garage or something, the box. And I do that with everything. And then after a while, I toss the boxes out because they're empty anyhow. But anyhow, so far the 350 skimmer is doing great on the aquarium. I have no complaint. It does suck in a little bit of air like all those skimmers do that are designed to go in the canister like this, but it just blows it out into aquarium. Where if you connect the ones up to your canister, that air's got to go through your canister and it's got to go, and hopefully your impeller will blow the air out of your canister and not airlock it. Trust me, it's happened to me. I've had a canister airlock where it got too much um, air into the head of the canister, and it literally was just running. You can hear there was water in it, but nothing was coming out of the exit until you either shake it or you stop the whole canister. And then I realized it was from adding one of these onto a canister filter. It's happened. That's why I just made mention of it, that forewarned is foretold. If you buy these that you add onto your canister skimmers, there is a chance that they can't suck in air. Like this sucks in air too, but it just blows it out into aquarium. There's nothing's going to get airlocked. So anyhow, if you watch my video and I show you how to do the modification on it or how to fix it so you won't have a problem, and you shouldn't have a problem. It's very quiet, very, very nice. You can use it on all size aquariums, and they do have a, what should I say, a knockoff. And I heard one of the biggest problems are the suction cups keep, people suction cup it on and they're not holding. So the thing keeps falling, and one guy even showed a picture of a fish that got stuck in the tube here because it fell, I guess, and a fish went inside there and got sucked up in there. Like I said, all kinds of accidents can happen when you're in this aquarium trade. And I was surprised at the size of fish that got sucked up into this. But anyhow, this particular video is not about that. The particular video that I'm going to show you is about a guy named Sid Mitchell and what he wrote about the Anoxic Filtration System. Sid Mitchell, like Dr. Franco in Italy, Sid Mitchell is from the United Kingdom, and he's written extensively about the Anoxic Filtration System. So I'm going to read you what he has written about it. You will be explained on how the BCB basket works. You're going to get formulas of bacteria. Now, when he talks a little different. There are words that I use. You'll notice that, like I'll say bacteria or I'll say cells, and meaning the same thing as bacteria. Now he'll use the word bugs. Same thing. He's just talking about bacteria. So yeah, you could hear the word bacteria, or they'll say the cells will multiply and they'll double in every 24 hours. You're still talking about bacteria, cells. He uses the word in reference to it to make it more user friendly, if you want to say that in his writings, the word bug. So the next video, maybe two videos, because I don't want to make them too long. I don't want you, to get bored or anything, which I'm sure a lot of people have gotten bored over my videos. They become too long. I may have to do it in two parts, and I'm going to tell you what he has said. You're going to get a lot of information, chemical equations on this. People have asked me, they want to hear more of this stuff on chemical equations, and is there a chemical equation even for bacteria? Yes, there is. So we're going to get into that. We're going to get into a lot of what Sid has written about to educate the European hobbyists, along with what Dr. Franco has written about in Italy. And I've known Sid for years. Okay, very nice guy. He became very adamant about the anoxic filtration. When he heard about it, he wrote me and said, hey, what about this that I've been hearing? And ever since then, he's been writing about it, educating people over on the European side, or should I say, at least in the UK. Okay, any of your English-speaking countries, but there's a lot of countries that speak English. So he's kind of been carrying the ball over there where I've been carrying the ball over here in the United States. So that's what this video that's coming up going to be about. And in a way, you can kind of say the next video or two is going to be dedicated to Sid Mitchell for all the work he has done and try to help educate people on the anoxic filtration system and how it works and everything else. Okay, so stay tuned. Take a planting basket, fill it with cat litter, then scoop out a depression in the center and fill that depression with aquarium plant fertilizer called laterite. Put a plant into the basket if you wish, but it is not necessary. If it is that simple and inexpensive to make a biocenosis clarification basket, otherwise known as a BCB, why are more koi keepers, pond keepers, and aquarists not using the anoxic filtration system? Possibly the answer lies in the fact that it is rare to find a pond keeper who actually understands what anoxic filtration actually is, what it does, and how it works. The reason for this lack of understanding should immediately be obvious. Already I have used 3 words that many pond hobbyists and aquarists will find new and mysterious. What is laterite? What is a biocenosis clarification basket? And isn't anoxic something to do with anaerobic sludge where harmful bacteria can live? If it were possible to describe the anoxic filtration system without using such words, I would do so. But why it is easy to build the system, the way it works is extremely complicated. So let us begin by explaining what laterite, biocenosis, and anoxic mean. Laterite is easy enough to understand. It is simply a clay-based material that is rich in iron. It is used in tropical fish tanks as a plant fertilizer and can be bought from tropical fish dealers. You can also buy it, of course, we all know, on the internet. Most fish dealers, I don't think, are carrying laterite. Biocenosis. This is a scientific term for a place where different biological processes take place, each process being of mutual benefit to the other process. Watch my earlier videos, I kind of explained that, how different levels of, let's say, a plenum work, and all those processes benefit another process that's happening in the plenum for our aquariums. A plenum is basically a BCB basket, but we're just putting it in an aquarium. You're doing the same process, okay? Whether it is a slow-moving one, or whether it is a static one that you're not even using any kind of bubblers or not. And it will work the same way, and I've explained that in earlier videos. Anoxic. The word anoxic does not mean the same as anaerobic. In an anaerobic region, there is a complete absence of oxygen. In an anoxic situation, there's oxygen present, but in very low levels. In a BCB, there is always a low level of oxygen. Levels are typically between 0.5 parts per million to 2 parts per million. This is also the same as if you make a plenum, and if it is thick enough, this same process will be like at the bottom of the plenum. This is a key factor what will influence a situation where anoxic filtration can occur. The absence of extremely low levels of oxygen is critical to the system, as will be described later. In passing, it might be worthwhile to contrast the oxygen level in a biocenosis clarification basket with the oxygen level in a pond or aquarium itself. The absolute minimum acceptable oxygen level in a pond or an aquarium is 6 parts per million. Although 7 parts per million is more often recommended as a safer minimum to adopt, and in practice it should be at saturation levels as high as possible at any given temperature. And as has been explained, that as the temperature goes up, there's less oxygen, and your plants will only start photosynthesizing or making the purling of bubbles when the aquarium becomes completely saturated with oxygen at that particular temperature level. Then you will see the purling of the bubbles. With the first few terms explained, it should now be possible to move on to a better understanding of how the anoxic filter system is quite unlike any filtering system that is commonly in use by pond and aquarium keepers. There will be more complicated terms as the description unfolds, but each will be explained as we explore the system. To contrast anoxic filtration with conventional filtration, it is first necessary to understand how biological filters actually work. Conventional biological filters first continually excrete ammonia which is toxic to fish. Okay, and so it has to be removed from the pond or aquarium water before it can cause them harm. We all know this, as well as design and conventional biological filter systems will be effective at taking this ammonia and converting it first into nitrite and then into nitrate by a process called the nitrogen cycle. This is also well known, having achieved the conversion of ammonia into nitrate. The task of conventional biological filter is complete. No further biological action to remove the nitrate takes place as to level the nitrate and the water slowly rises. This is first disadvantage of conventional biofilter systems. As I've explained in earlier videos, this is why a lot of people, when they talk about the nitrogen cycle, they pretty much ended at nitrates. But that is really not the end of the nitrogen cycle. But basically, that's what we've been taught. Nitrate is nowhere as toxic to our animals as either ammonia or nitrite, but that doesn't mean that they are not affected by it. Hard scientific research on this subject is difficult to come by, but there is plenty of anecdotal evidence to show that koi kept in low nitrate, for example, ponds, show better growth and color development than those kept in ponds where the nitrate level has been allowed to rise. Easier to prove is effect that nitrate has on algae of all types. Nitrate is a plant fertilizer. A rising level will encourage blanket weed and the kind of algae that turns water green. Water changes will help, but even after a 10% water change, the nitrate level will still be 90% of the original value, and as more ammonia is converted, the nitrate level will soon begin to rise again, as we all know. And that's why people are trying to use plants to take care of the nitrates. But this, as we know, runs into other problems, right? If your plants aren't photosynthesizing at 100%, and we know that 1/3 of the energy of the plant is taken away from it to convert the nitrate back into ammonia. if you watch my other videos. So they're not working as efficiently as possible, plus the fact that they can only convert the nitrate that's in the water back to ammonia only during peak photosynthesis, because it takes a lot of energy to do so. Okay? There is a second problem with some conventional biological systems, which is that the biological media can become anaerobic. That means no oxygen at all. This will not occur with a moving medium such as fluidized sand or aerated K1, but where the medium is static. Water flow through it carries suspended particulate matter as it passes through. This will settle within the media and over time can cause it to block. Also, what causes filters to block and everything else is the polymeric adhesive that bacteria give off in order to prevent water shear. So as your canister filter is running, or your filter is running, that polymeric adhesive also helps in clogging up your media. Okay, because that's just the way it goes, because it's trying to stick onto the media as water is passing through it. The faster the water, the more polymeric adhesive, the more cells live and die throughout that. They continuously do that, and they build up a slime. Like, for example, especially in ponds, if you rub your finger inside of a pipe, you will feel that slime. That's that polymeric adhesive from the bacteria. Water will not easily be able to pass through blocked areas and will tend to bypass them. The water will find it easier to flow through areas that are not blocked. Yet, water flowing through media carries oxygen to the bacteria that are living in it. As the flow through a particular area reduces, the bacteria in it will find that there is less and less oxygen in their environment. The bacteria that have been oxidizing ammonia, first to nitrite and then to nitrate, will have been using a great deal of oxygen to do this. As the media becomes clogged, they will find that they no longer have the oxygen available to carry out this process. There are bacteria that need oxygen as part of their biochemistry, but in some ways can be thought of as being far more clever than we are. If we are deprived of oxygen, we soon die. But these specialized bacteria normally take the oxygen that they need directly from the water surrounding them. But if there is no oxygen in the water, there is a way they can get it. These specialized bacteria, they can take oxygen from nitrate. Nitrate, which is NO3, is the end product of the nitrogen cycle as far as pond keepers and aquariums are concerned. It consists of one atom of nitrogen joined to 3 atoms of oxygen. These bugs can take away the atoms of oxygen from nitrate. In doing so, they reverse the nitrogen cycle. Our 2 favorite nitrogen cycle bugs, Nitrosomatus and Nitrobacteria, will be as busy as ever converting ammonia to nitrate in the aerobic areas of the biological filter. But bugs that can live in anaerobic conditions will rapidly colonize the anaerobic areas and will become equally busy taking the oxygen that they need from the nitrate that has just been produced by their cousins. This will result in that nitrate being converted back to ammonia again before it leaves. This is a completely pointless exercise, yet it is exactly what is happening in many filtration systems where the biological media is not clean. At least part of the good work being done by the bugs in the oxygen-rich areas is being undone by the bugs in the areas that are deprived of oxygen. I've explained that by putting your substrate directly on the bottom. This is exactly what happens. It happens in very dirty filters, and it happens in the pond a lot when people like put rocks and stones in their ponds, and they begin to clog up with detritus and leaves and dirt from the air that gets into the pond. The Anoxic Filtration System was designed and has been developed over many years by Dr. Kevin Novak, and it has addressed both these problems. The Anoxic system does not rely on converting ammonia to nitrite and then into nitrate. With the Anoxic system, ammonia is either converted directly to nitrogen gas, more correctly called denitrogen, by bacterial action in the unplanted basket, or for that matter, it would be unplanted aquarium also, using a plenum, or it takes up by the plant roots in the basket that are also contain plants, or into your substrate in the aquarium. It is well known that plants like to feed on nitrate. What is less well known is that plants actually prefer ammonia as a food source and will take it directly from the aquarium or pond water if it can be presented to the root system in the correct way. The processes that cause this to happen will be described in detail in part 2 of this video. But for now, please just accept that ammonia molecules are attracted into the baskets or the plenum by the laterite that we put into the center. Plants, as I have explained, 1/3 of their energy is used to convert nitrate back into ammonia because that is what they need. This is how hobbyists get fooled and tricked into thinking that nitrates are number one what plants are looking for. Another important feature to understand is that it is only the ammonia molecule that are drawn into the biosinosis clarification basket. Obviously, water floods into them when they are emerged, but after that, water does not actually need to flow through them in order to filter out ammonia. The laterite in the center of the basket only draws in ammonia molecules. It does not draw in water molecules. This directly addresses the second possible problem that can happen with some of the static type of conventional filter media. I mentioned earlier that suspended particulates can clog media and it will then become anaerobic. Yet water will move in and out of a plenum or a BCB basket through convectional means or through diffusion. Okay, we do understand that. Okay, critics that have not taken the trouble to understand how the Anoxic system works often wrongly describe it as a bog filter, full of nasty anaerobic bacteria. They warn that the baskets are a breeding ground for parasitic bugs that can then spread to your fish. In fact, the direct opposite is true. Biosinosis clarification baskets cannot clog because if no water flows through them, there is no way that detritus can be carried inside. On the other hand, if water flows through, conventional media does not have every speck of debris filtered out of it. There will always be the risk that sludge will settle inside and block the media. So far from a biosinosis clarification basket being a bog filter, it is more likely that this label could be applied to a conventional system that has not been kept sufficiently clean. Okay, the pictures that I'm showing you above are typical Anoxic filtration pond without the plant. It is simply a shallow pond around 24 inches deep with water being pumped into the end, overflow by gravity back into the main pond at the other. The one contains 22 biosinosis baskets. The small pebbles on top of the basket prevent water flow past them from disturbing the cat litter that's in the basket. So you put the pebbles, this is for pond use, inside, causing it to float away. The other photographs show you an entire Anoxic filtration system that can be hidden in plain sight. The Anoxic pond looks like a water garden, not a filter, and yet everything except the pump in the main pond can be clearly seen. For those who do not like pump-fed systems, the Anoxic pond can be gravity-fed from a bottom drain. Build the Anoxic pond at the same level as a conventional gravity-fed system and use a submersible pump or external dry mount pump to pump water from the Anoxic pond back into the main pond. The only limit to how this system can be built or adapted is your ingenuity. There are a few hard, fast rules as to how to make a biocenosis basket. It is important that planting baskets used should be open lattice type sides that allow ammonia to be drawn in through them. But apart from that, any basket around 30 centimeters by 30 centimeters by 20 centimeters deep will do. Now this is for pond use. For aquarium use, if you wanted to make a basket, it could be smaller. As I show in my older videos, I have baskets that are 4 by 4 by 4. Okay, it's up to the hobbyists on how big they're going to make it for their applications. If they're using a sump, not using a sump, using a canister filter, as I've shown how big I've made them. So that all can be changed, but this is kind of just telling you about like if you're using it for a pond. The cat litter should be of granular, unscented, non-clumping type that should retain its granular structure when wet. Also, you can use laterite, and there's not laterite, but you can use oil dry or safety zorb. There's other products out there made by the same company, by the way. Laterite can be obtained from tropical fish outlets or purchased online in 1.6 kilogram baskets or less. And he states in here, in Great Britain, it's about 25 pounds. Biocenosis clarification baskets need very little maintenance because the life of the cat litter is indefinite, and the laterite is only very slowly depleted by plants. Photosynthesis is a process that plants use to make energy from sunlight, and a green pigment called chlorophyll is essential for this process. Plants need iron to make chlorophyll, so if there is a plant in the biocenosis basket, the iron in the laterite will become exhausted after about 5 to 10 years, and you will have to add some more laterite or remake the basket. This goes for everything. Laterite, a lot of people ask me, what is the laterite for, or why are we using iron like in the aquarium? Well, iron is very crucial in not only plants, but in the processing of bacteria. Bacteria use a lot of iron to begin their cell development. Okay, so that's why we use iron. Let's see, and that's about it for part one, because it is getting kind of lengthy. Part two, it's going to get more entailed. We're going to get into more chemistry. We're going to get into more formulas. Formulas that you as hobbyists have never even seen before, explaining what nitrosomatis eats and what nitrobacteria eat. We're going to get into the chemical formulas of that, and we're going to explain exactly what happens to a BCB or what happens to a plenum and in more detail. So we're going to get a lot more complicated in the next video. So if you found this one boring, the part two is going to be a lot more boring than this one. Okay? Until next time, thank you for watching. This is Dr. Novak.